Hi again. We are going to continue the topic on compressor. So this is the third video with regards to the axial flow. We have gone through in the previous two videos on axial flow compressor that covers the overview, the principles of operation and construction of the compressor. So for today, the last video on axial flow compressor will covers the rotors, rotor blades as well as the stator vanes. In compressor designs, the rotational speed is such that a disc is required to support the centrifugal blade load. So that's why in the previous video, I have shown you the photo of the stator vanes that are being constructed within the casing of the where a number of discs are fitted onto one shaft. They may be coupled and secured together by a mechanical fixing. Generally, the discs are assembled and welded together. This is just another figure showing the construction of. In this particular slide, fixing may be circumferential or axial to suit special requirements of the stage. The aim is to design a securing feature that imparts the lightest possible loads on the supporting disc, thus minimizing this weight. So you can see that in terms of the setting up of the rotors, okay, it is being inserted into a root area, okay, there's a slot there, and normally being secured by certain mechanism. Now we've moved on to the rotor blades. Rotor blades are of airfoil section. Okay, so you can see some of the rotor blades are having twist angle, and it is usually designed to give a pressure gradient along their length to ensure that the air maintains a reasonably uniform axial velocity. So the higher pressure towards the tip balances out the centrifugal action of the rotor on the airstream. So this particular blade, we have the length there, we have the tip, we have the root section. So normally the direction of the flow is in this way, the direction of the rotation is in the downward way. To obtain these conditions, it is necessary to twist the blade. You can see from the previous slide as well as in this particular photo, the blades are in a twisting mode from the root to the tip. So from the root to the tip, okay, to give the correct angle of incidence at each point. Air flowing through the compressor creates two boundary layers of slow to stagnant air on the inner and outer walls. In terms of the cross section, okay, this is a cutaway of a typical compressor rotor blades. In order to compensate for the slow air in the boundary layer, a localized increase in the blade chamber, both at the tip as well as the root, has been introduced. So this is what we call it as the blade chamber. There will be air flowing into the section. Now we go into the stator vanes. This is a typical picture of a stator vanes. It is being secured piece by piece into the inner ring. The stator vanes are again of airfoil section and are secured into the compressor casing or into the stator vane retaining rings. So you can have a two different mode of configuration which are themselves secured to the casing. So you can see here a typical cutaway on how the stator vanes being secured. The vanes are often assembled in segments in front stages and may be shrouded at their end to minimize the vibrational effect of flow variations on the longer vanes. So you imagine there are certain cases the vanes are longer and there are certain cases the vanes are a bit shorter. It is also necessary to lock the stator vanes in such manner that they will not rotate around the casing. So you can see here in this particular photo, there are retaining set screw to secure the stator vanes onto the retaining ring. Right? That's all for now. We will continue with the following compressor topic, which involve operating conditions. Bye.